All right, welcome to Absolute Value Transformations, Level 3. Now, in this one, we take a look at our g of x. Oh, and by the way, let's go ahead and say this. Our vertex form for the absolute value function is a absolute value x minus h, close absolute value, plus k. And let's see what we have over here on our g of x. So we'll say, okay, you know this 2 is in front of the f of x, that's our a term. So I can say, okay, well, a is equal to 2. And then here we have this plus 5. We'll notice that it's on the outside, so that must be my k term. I can say, you know what, k is equal to 5. So let's think about it. What are my rules? Well, when a is greater than 1, we have what's called a vertical stretch. And when k is equal to 5, we know that k translates us up or down. So we say, okay, well, this translates us up 5. All right. Now remember, we're always going to have to compare this to our parent function. So my parent function is f of x equals the absolute value of x. It starts at the origin, and it essentially goes up 1, right 1, up 1, right 1. And then this is, of course, mirrored in the other direction. Okay. Well, let's take a look at g of x. So we can say, you know what, g of x is equal to, since our a value is 2, that means we're doing 2 times f of x. F of x is the absolute value of x. And then we have this plus 5 on the outside, so outside of my absolute value bars, I write plus 5. And let's see how this actually graphs. We know that there's no change in h, so our x value must be 0. And we know that our k value is 5. Remember, our vertex is at h comma k. That's our vertex. And so this is just telling us to translate up 5. So we go up 1, 2, 3, 4, 5, and put our very first point. Now from here, we see that our a value is equal to 2, or aka 2 over 1. And so that means we're going to go up 2 units and to the right 1, and we can see that our graph has gotten narrower, or aka vertically stretched. So all we're doing here is combining our rules from the previous 2 lessons. All right, let's go ahead and look at example number 3, I believe. Okay, actually, let's do example 4. I think that one will be a little bit better. So let's kind of talk about what changes we have going on here. We can see our very first change. We see that our a value is negative. And we also see our a value is also in between 0 and 1. All right. And we see here inside the parentheses, we see that positive 2. So what we want is the value of x that makes our grouping equal to 0. So we can do this by saying, well, you know, x plus 2 is equal to 0. And how do you get rid of a plus 2? Minus 2, minus 2. And we can see that x is equal to negative 2, or aka our h value is equal to negative 2. All right, so let's go ahead and talk about our rules. We know that whenever we have a negative a value, we are reflecting down. Or we could say reflecting across the x-axis. We know that when our a value is between 0 and 1, or aka it's less than 1, we know that we have a vertical compression. And lastly, we know that whenever we have this x value, whenever our x value or our h value, when we say h is equal to negative 2, well, we know that, let's see here, we'll say h is equal to negative 2. We are going to translate 2 units left. All right, and here are my rules. Okay, so let's go ahead and first graph our parent function. Tell you what, let's use kind of this neon purple. And we know that it's here at the origin. We go up 1 and to the right 1. And then from there, we can just kind of mirror our line on the other side. But let's take a look at g of x. So g of x, this function right here, we'd say, okay, well, g of x has the a term of negative 1/2. And then we see our function, which is the absolute value of x. But notice we have this plus 2 on the inside of the function, so I'd write absolute value of x plus 2. And then from there, we can say, okay, well, you know what? It's going to reflect down. And we have a slope of 1 over 2, so we go to down 1 and to the right 2. And we can go down 1 and to the right 2 again. And you'll notice that this time our line has actually gotten wider. Oh, and the other thing, oh, I'm so sorry. Remember, our x value is negative 2. Since there's nothing out here, it's like saying plus 0. So we'll go, okay, we're going to go to the left 2. And then from this point, I'm so sorry, from this point we're going to go down 1 and to the right 2, and down 1 and to the right 2. And then here we see, okay, our graph is reflected down, and it's much wider than the original function. All right, let's go ahead and do one more of these, and let's kind of put everything together. Okay, let's take a look at number 7, just because I think this one looks a little bit tricky. Let's say, you know what, here. I'm going to go ahead and write our parent function again. We have the absolute value of x. And let's go ahead and see what happens when I transform it using g of x. So we'll say, okay, g of x is equal to the negative of this function. So we'll put a negative symbol outside our absolute value of x. And then we want to determine, is this minus 6 inside the parentheses or is it on the outside? Well, clearly it's on the inside. So inside the absolute value, I'll put my x minus 6. Now let's go ahead and graph our parent function. We see here it's at the origin. It goes up 1 and to the right 1. And we can graph it as such. But here, our g of x is a little bit more interesting. We say, okay, what value of x will make this grouping equal to 0? Well, if I add 6 to both sides, I get x is equal to positive 6. So I know that my vertex is at positive 6, comma, and since there's nothing on the outside, comma 0. So I go to the right, 1, 2, 3, 4, 5, 6. And from here, this is the part I don't want you to get confused on. It's really like saying there's a negative 1 in front of this for our a terms. That's like saying negative 1 over 1. So we just go down 1 and to the right 1, and we can see our graph looks something like this. All right, so all this thing did, if we want to write out our rules, we'll say it reflected across the x-axis and translated 6 units right. All right, I hope this was helpful, and I'll see y'all in our level 4 video.